quite often in a maths problem, we know some information, excuse me, and we're trying to find the missing values. So in this first one, we know the x-intercept is -1, 0. Now I need to know that that means I can sub -1 in for x into this equation and 0 in for y, and that equation will be satisfied if I sub that coordinate in. And that's because the line is going through that point. Oh, I've drawn it wrong. Like this. So the line is going through the point -1, 0, and that means that the line itself satisfies -1 plus 2 lots of 0 plus whatever p is, because it's always the same p, is 0. So -1 plus p is 0, so p must equal 1. In the second part of this question, we need to know how to find the gradient. So I always put arrows on the coordinates like this. The top is dy and the bottom is dx. Now dy is the change in y and dx is the change in x. And I would always do the second one minus the first one. So in this case, dy by dx is equal to 3k minus 2 on the top and k minus 7 on the bottom. And we're told that that's 4. We know that dy by dx is 4, the gradient's 4. 3k minus 2, k minus 7, times both sides by k minus 7. Once you've set the equation up, it's relatively straightforward to solve it. 3k minus 2, k equals 26. And finally, the fact that I'm going to use is that the area of a triangle is half base times height. But base and height, don't forget, they depend on what your triangle looks like, so let's draw it. Any questions to do with, triangles, circles, lines? Don't forget these are geometry questions. And geometry questions always need pictures to inform what we're doing. So in this case, we've got a triangle. And we know one of the coordinates is at -4, -2. So I'm going to draw that there. This is the point -2. This is the point -4. And we've got another point at 0, -3. That's here. So that's there. So that's one side of our triangle, definitely. Now we've got another point. We don't actually know where it is, but we do know that it's the point k minus 1, comma, -2. So the y coordinate is on this line here. Now, there's three possibilities. Either the point could be here, to the left of the point A, or the point could be maybe in between the point A and the y-axis, or maybe it's right over here. Now, in each of these cases, we're going to have to work out the area and see if it makes sense. Because I haven't been told anything about k minus 1. If I was told k minus 1 was positive, that'd be easy. It would be the yellow dot. And if I was told that k minus 1 was between 0 and -4, that would be easy. It'd be the green dot, but I don't know, so I'm going to have to do all of them. I'll do yellow first. So this point here is k minus 1, which I'm assuming is bigger than 0. So I'm basically saying k is bigger than 1. So I'm on the right-hand side somewhere. So here's my triangle, there and there and there. And I'm going to use this as the base, and then that means that this is the perpendicular height. So using the area of a triangle formula, a half base times height. Now the base is going from -4 to the origin, and that's 4, and then it keeps going another k minus 1. So there's the base, and the height, well, the height is going from -2 to -3, so it's gone down 1, so it's a height of 1. And I know what that area is. I've been told it's 3 over 2. So I'm going to double both sides, giving me 4 plus k minus 1 is 3. So k plus 3 is 3. So k is 0. Now, does that make sense? No, it doesn't. I said k was bigger than 1, and now I'm saying k is 0. So this doesn't make sense. The yellow triangle can't be right. Let's try the red triangle. So now I've got the base here, and I've got that line still, and I've got the same height as before, so it's the same perpendicular height here. So all I need to do is work out the base. That's the difficult bit, and this is going to be the point k minus 1 here. Now, I'm now, with the red triangle, saying that k minus 1 is even smaller than -4. So I'm saying that k has to be less than -3. That's what I'm basically saying, and that's why the triangle looks the way it does. So how big would that base be? That's the difficult bit because the height is still 1. The base is going to be, well, if we measure all the way from the origin back to 4, it's a distance of 4. So I wouldn't say that length there, that distance is -4. I'd say it's a distance of 4. And all I've done is kind of take the minus off, or you could think of it as putting another minus on, -4. So all the way across from the origin back to k minus 1 is a number k minus 1, but that's negative, like the -4. So actually the positiveness would be minus that number. That's quite complicated, but basically this is a negative number, like the -4. So this is a now positive number, which is that length from the origin to the point k minus 1. And then I'm going to take 4 off that, because that's the distance from the origin to the other point, and then that's going to give me the base. The height is 1, and we know the area is 3/2. Let's see what we get now. So doubling both sides, minus k minus 1 minus 4 is equal to 3. So minus k plus 1 minus 4 is equal to 3. Minus k, what's that? Minus 3 on the other side, plus 3 is 6. K is minus 6. Does that make sense? Yeah. I said k was less than minus 3. Minus 6 is less than minus 3. So this is a definite contender for the value of k that works for this triangle. We've got one more to try, which is the green one. So in this case, our base here goes to the right of -4. So I'm assuming now that k minus 1 is negative, it's less than 0, but it's bigger than -4. If I add 1 to all of these, I'm basically saying that k is between -5 and 1. That's what I'm saying, and that will end up with this picture here. So the base is there, and the height is exactly the same as before. Perpendicular height is 1. So all we need to do is work out that base. So all the way from here to here is 4, but I want to take away this distance here. Now this distance here, don't forget, k minus 1 is a negative number. So if I just write k minus 1, I'll be taking away a negative, so I'll actually be adding. So what I need to do is take away the negative version of k minus 1. Again, this is complicated, but think of it this way. This is a negative number, for example, -2. If I want to work out how far it is from -4 to -2, I don't do 4 minus -2, because then it would be telling me that this distance here was 4 minus -2, which is 6, which is obviously rubbish because the distance is 2. So by sticking this minus on, what I'm doing is I'm making this a positive length, and then I can subtract that from the positive length, 4. So we know the answer is 3/2. So doubling both sides, 4 plus k minus 1 is 3. So k plus 3 is 3, and again, this isn't working, we're coming out with 0. Oh no, that is working. K could be 0, because 0 is between -5 and 1. -5 there, 1 there, here's 0, that works. So one possibility is 0, and one possibility is 6. -6. I'm just going to check those so that you can see that I'm not making it up. So in the red scenario, we worked out that k was -6. That gives us a coordinate of -7 minus 2. If this is -7 and this is -4, then the base is length 3. The height, perpendicular height, is length 1, because it's going. So the area is 1/2 base height 3/2, correct. Green one. Now our second point, instead of being on the left-hand side of 4 minus 2, it's now on the right-hand side of 4 minus 2. So our base is going from -4 down to -1, which again is a length of 3. Again, perpendicular height, same, going to be 1, because it's going from -2 to -3. So the area is 1/2 base height 3/2. So all geometry questions, the lesson here, you must have pictures in your mind. You can't just do algebra.